All right, so this is the next video, or a video, on logarithms. So this video we're going to be concentrating on properties of logarithms. So overall, I would say that knowing the properties of logs is probably the most important piece of logs, meaning that the stuff that we're going to cover in this video is usually the most often sort of used in practice pieces of information. And this is in pre-calc for like exam questions, quiz questions, projects, stuff like that, but also in calculus. So in particular, some of the things that logs let you do with these properties allow for very clever ways of doing things like derivatives and limits and things in Calc 1 and even in Calc 2. So they have entire sections like logarithmic differentiation and logarithmic limits and all kinds of things. So these are sort of the parts about logs that you really want to get down, especially if you're going into calculus. So I'm going to go through sort of three main properties, although I have a property 0 to remind you from the introduction portion. And then I'm going to mention sort of a couple things that aren't really properties. They're more just applications of those properties, but they're really common to run into. So they're sort of a nice shortcut and things to keep in mind. So first thing I'm going to do here, like I said, I'm going to start with a property 0. So this is just a reminder. So remember that we had said that logarithms are sort of defined to be the inverse function of the exponential functions, meaning that if we have so if f of x, the function, is say some b to the x, right, some exponential function like 2 to the x, e to the x, 5 to the x, whatever, then the inverse function f inverse of x is log with that same base b of x. And as we mentioned when we talked about inverse functions, but just to recall, the whole idea of an inverse function, right, is that f inverse of f of x is x, and because this is important, f of f inverse of x is x. So what this is really saying then, in terms of these things, is that if I have some log base b, right, on the outside of b of x, so maybe I'll just pair them up here. If I have log base b of b of x, that is just x. And likewise, if I have b and then to the log base b of x, this is also just x. Okay? So my sort of property 0, as it were, this is just saying, essentially recalling exactly what the definition of the log is, which is this piece, these two, which are super useful and going to be very important for the next parts that we do. So I'm going to show the sort of how to derive these properties, meaning that these are not things that are true by definition. These are things that have to be true or arithmetic stops working. But I will sum up the properties at the end as the sort of one-line equality that you're used to seeing. Okay? So let's start with property 1. So let's say we have log base b of x plus log base b of y. Let's say we're adding two logarithms together, okay? So these things, right, the log base b of x, whatever b is, whatever x is, this should be, like, if I plugged in numbers for that, that would be a number, that would be a number. Adding two numbers together is a number. I'm going to make this, I'm just going to sort of define this to be some z thing, okay? So I'm just saying whatever this equals, I'm going to call it z for a second, okay? And then I'm gonna remember these properties here, okay? So in particular, I'm going to look at the this piece here for a z, meaning that I'm gonna write log base b of b to the z equals z. So this is true for any z. It's therefore true for this particular z, right? This would be true no matter what thing I put in here as z, but my z is this. So I'm going to substitute that in. I'm literally just going to take z and plug it in where there are z's. So I'm going to have log base b of, so I'm going to have b to the z. So I'm going to have b to the log base b of x plus log base b of y. All right, so that was plugging in one of the z's. And that equals, again, what z is. Maybe for the sake of writing sort of too much, I'm just going to keep that as z for a second. I'll substitute that one out later. So this is still just sitting there. I'm just going to have this hang out for a second. Log base b. But here, I have exponent to a thing plus a thing, right? So I'm just going to remind you, or sort of note down here, right? So if I have some b to the a plus c, this is the same as b to the a times b to the c. This is one of those rules of exponents, right? So this is exactly what I'm going to do here. I have the a plus c. So in fact, maybe it would even be better. Sorry, I just thought of this on the fly, but why not, right? So why don't I do, if I can actually get this to erase nicely, like that. So why don't I do this, and then I can show with some color. Hopefully that shows up. I don't know if that's, I might cut this through, cut this in editing, but let me make it a different color entirely. So let me do C and C. Okay. So I have B to the first thing. So this is log base B of x. And then I'm multiplying again by b, and then I have the second thing. So this is now log base b of y. And I can close that off. That's still equal to z. Okay? So I'm just showing, right, I'm splitting the plus sign and putting b times for both of these, right? But here's the thing, remember, b to the log of stuff just gets me that stuff. So I have b to the log base b of stuff. So I get just the stuff for both of these, right? So I still have the log base b on the outside. But b to the log base b of x becomes simply x. It's being multiplied. And then log b to the log base b of y becomes just y. And now I'm going to write this out with what z is, but I'm going to do it with color so that you can see what's happened. So remember, z is log base b of x plus log base b of y. So I have log base b of x plus log base b of y. Okay? And in fact, this right here is property 1, meaning we have log base b of x times y is log base b of x plus log base b of y. Okay? So it's literally this, but I'm going to write this up here. So if we have log of any base of xy, that is the same as log of that base of x plus log of that base y. Okay? So I want to point out here that the product, right? We have product inside the log, sum outside the log, okay? So this is one of those really common errors, is which one is where? Is it log base b of x times log base b of y? Is it x plus y in here? Or the other way? So I want to make sure it's very clear, right? Log base b, product inside, adding on the outside. A useful mnemonic, which we'll talk about when we go into, on the video with common errors, excuse me, then sort of useful observation is that there's no products of log terms. Meaning I don't have log base b of stuff times log base b of stuff. Same with division. I don't have log base b of something divided by log base b of something, right? Each term has exactly one log component to it, okay? All right, so I'm going to erase the board, so I'll probably do some editing, teleport around, so the board will be clean, and that way I can go and do the other two properties. So abracadabra. Okay, so I cleaned off the board and I rewrote in sort of a condensed form, right, our property 0, property 1. So next up, we're going to do property 2. So this property really follows from the first property sort of directly. So yeah, the question here is, so what happens, or consider the case where we have some log base b of number to a power. So I'll write it as, let's say, 4 to the third, okay, for any base b. Now, I can think of this as 4 to the third, but I could also write this sort of exactly what it is, which is log base b of 4 times 4 times 4, right? That's just what 4 to the third means. But as we saw, right, in our first property, products inside, right, become addition outside. So I can take the products here and make them into addition, meaning that I can write this as log base b of 4 plus log base b of 4 plus log base b of 4, okay? But these are all the same thing, right? Log base b of 4, each of them. I have 3 of them, so I could write this as 3 times log base b of 4. And the key observation here is that that 3 came from the fact that I had 3 of these, because I had 3 of those, because I had that 3. And so our second property is that if we have, so in fact, let me actually just write it over here. So let me do this. So if we have log base b of, again, any base we want, so I'm going to say some, so we used 4 as an example, but let's say we use c. In fact, actually I'm going to use a. A weird looking a now, but an a nonetheless. So let's say we have a to the c power. Then this is, take that and bring it in front. So we're going to have c times log base b of a. So let's multiply right there, okay? So this is our second property. If we have something to a power, we can make it as that power times this. Now, this follows for whole powers, as I just showed you, but it actually turns out that this will work for any finite real number. So c here could be like 5, but it could also be -3 or 1/2 or whatever. Any real power, right, any real number. Don't want to worry about complex numbers with this. That's a whole bag of worms, right? So any real number here that's finite, you can pop out front, okay? All right, last but not least, for our important properties at least, property 3. So this one is basically going to be a merge of the other two. So in particular, let's consider what happens if we had something like log base b of x over y. Okay? So I'm going to do just some straight up arithmetic, so maybe I'll even write it off to the side here. X over y, right, I can just write this as x times 1 over y, which is really just x times y to the negative 1, right? So I can rewrite this thing then in sort of a very basic way, but important way. Wow, it's not an equal sign. Log of. So instead of x over y, I'm going to write it as x times y to the minus 1. Okay? Now using property 1, I can make that multiplication right into an addition. So by property 1, I can make this into log base b of x plus log base b of y to the minus 1, right? But this is y to a power, so using property 2, this thing is still the same, log base b of x plus, and now I can pull that as a power in front, negative 1 times log base b of y. That sort of got a little weird, sorry. There we go. Okay. And I'm just going to clean that up just a little bit. So this is then log base b of x minus log base b of y. Okay. And in fact, this is, sort of unsurprisingly, this is property 3. So if I do, let's use this color. So property 3. So in general, if I have log for any base b, I'm going to take a second to really reiterate here. Remember from the intro video, this base can be any base, including e, right? So all of these could be ln's to be natural logs. All of these things still exactly the same properties. So log base b of, again, I'm going to use some coloring here, x over y so this is log base b of x and then minus log base b of y. Okay? So these are the 3 key properties right here. If you can remember these 3, you're basically golden, with this one being the definitions. You should know that one as well. But these are the really important properties, okay? And all 3 of them show up a lot. Now, I also mentioned there were a few other things I wanted to sort of show real quick that come up a lot, but aren't themselves properties. They're just sort of specific instances of these properties. So I'm going to just box it off because these are all quick and small applications of these things. So first and foremost, so log base b of any b of 1 is 0. And this is pretty easy to see that this is true, as well as the next one, if you look at the exponential version, because the exponential form of this is b to the 0 equals 1, and of course that's true for any b, right? Because any finite, right? Remember, finite b to the 0, except possibly 0, is 1, okay? Similarly, meaning for the same sort of general reason, log base b of b is 1. And again, if we look at the exponential form of this, this is saying b to the 1 is b. And again, of course, this is true for, right, any b, any real number b that we're going to use. So these are sort of just the exponential form versus the regular form, versus the logarithmic form. The last one that comes up a lot, which comes up in two different sort of forms, even though they're the same thing. So log base b of x to the minus 1, which is the same as log base b of 1 over x, right? So this is just negative log of base b, base b of x. So this is literally just using this, right, this equation here with x being 1, right, and x down here being y, so whatever. The thing in the bottom is now x, thing in the top is 1, but log base b of 1 is 0, so you have 0 minus log base b of x. So it's just saying that it's a negative. So that's really pretty terribly written. So it is negative log base b of x. Maybe that's easier to read. Okay. All right, so those are all the properties and sort of the most common way that some of those properties show up. Although, again, I can't stress enough how important all three of these are. They show up a ton in calculus as well as in the exam stuff for the pre-calc. Okay? All right, so that concludes this video.